Good morning, students. Welcome to the 55 lecture of fluid mechanics subject. Today in this class, we will discuss about the concept of classification of orifices. In the last class, we have discussed about the various types of orifice meters. Now, in this class, we'll discuss about the classification of orifices. We are in the unit 4 of fluid mechanics subject. So we have completed the first part, the second part, and we have completed this one also. So now we are discussing the classification of orifices. In that we are having the small orifice and large orifice. So we will discuss this concept in this class. Yes. What is the meaning of orifice? So if you get a theoretical question in a part A, so you have to write this concept. Okay. An orifice is a small opening of any cross section on the side or at the bottom of the tank. For example, if you are having any rectangular tank, so when you are having any aperture at this place, or when you are having an aperture at this place, or whenever you are having an aperture means a small hole, a opening, or a orifice, right? Then if you see the cross section, so the cross section may be a circular cross section, a triangular cross section, a rectangular cross section. So what is your cross section? So when you cut this body, so it should look like the cross section is a circular, or the cross section is a rectangular type of thing, or it may be a triangle type of object, right? Then where the fluid is flowing. So just like if you take your water tank, your water tank. So for your water tank at the bottom, you are having an aperture where the water is flowing in this place. Okay, so through which the fluid is flowing. A mouthpiece is a short length of a pipe which is a 2 or 3 times its diameter in the length, fitted in the tank or vessel containing the fluid. Okay, then what is the meaning of mouthpiece here? It is a short length pipe where it is fitted to this aperture of the tank containing the water. Orifices as mouthpieces are used for measuring the rate of flow of fluid, right? So for example, if you are taking your water syntax tank, so for your syntax tank you are having a orifice or a opening, a small opening, a small diameter opening. So with that, in that opening, if you are fixing a mouthpiece, then this orifice as well as a mouthpiece, these two will act as a measuring part of flowing of a fluid, right? Then the classification of orifices. These are classified on the basis of their size and matter, based upon the shape, based upon the nature of discharge, how it is sending the fluid outside, it is sending slowly or it is sending fastly, or how orientation it is sending. For example, if your pipe is coming in the container. So the water will flow just normally like this. The water will flow from here to like this. The water will flow from here to like this. So this is the orientation of the discharge and the shape of the upstream edge. Then the various types of classification are, see the first one, small orifice or large orifice, right? So these are depending upon the size of the orifice and head of a liquid from the center of the orifice. So if the head of the liquid from the center of the orifice is more than the 5 times the depth of the orifice is called small orifice. Okay, then what is the meaning of small orifice? If the head of a liquid, the center of orifice is more than 5 times the depth of the orifice, then the orifice is called small orifice. And if the head of the liquid is less than the 5 times of the depth of the orifice, then it is known as large orifice. Then it is known as large orifice. 5 times is known as large orifice or small orifice, right? Then second classification. The orifices are also classified as a circular type of orifice, a triangular type of orifice, a rectangular type of orifice, a square type of orifice. Depends upon the cross sectional area. సో ఇందాక మనం చెప్పుకున్నట్టు, సో ఇట్ మే బి లైక్ క్రాస్ సెక్షన్ చేస్తే ఇలా ఉండొచ్చు, కట్ చేస్తే ఇలా ఉండొచ్చు, కట్ చేస్తే ఇలా ఉండొచ్చు, రైట్? దెన్ థర్డ్ వన్, the orifices are also classified as sharp edge orifice, bell mouthed orifice, depends upon the shape of upstream edge of the orifice. So ఇందాక మనం చెప్పుకున్నాం, depends upon the shape అని, right? So the shape, right? So the size వచ్చేసి large and small, nature of discharge, and the shape may be circular type, sharp edge type, or bell mounted type. Next, fourth, the orifices are also classified as free discharging orifices, drowned orifices, submerged orifices, depends upon the nature of the discharge. So here already I discussed that the orifices are classified based upon the size, shape, and nature of discharge. సో సైజ్ గురించి మాట్లాడుకున్నప్పుడు స్మాల్ ఆరిఫైస్ ఆర్ లార్జ్ ఆరిఫైస్, షేప్స్ గురించి మాట్లాడుకున్నప్పుడు వీఆర్ హ్యావింగ్ షార్ప్ ఎడ్జ్ ఆరిఫైస్ అండ్ బెల్ మౌత్డ్, రైట్? And coming to the nature of discharge, free discharge, drowned discharge, or submerged discharge. The submerged discharge are also further classified as fully submerged orifices, fully submerged orifices, partially submerged orifices. So like this, the orifices are classified based upon their size, shape, and nature of discharge. Got it? Next, flow through an orifice. Consider a tank fitted with a circular orifice in one of its sides as shown in the figure 7.1. Let H be the head of the liquid. H be the head of the liquid above the center of the orifice. The liquid flowing through the orifice forms a jet of liquid whose area of cross section is less than an orifice. The area of jet of a fluid goes on decreasing at the section C. Then the area is minimum. Okay, the area is minimum. This section is approximately at the distance half the diameter of the orifice. At this section, the streamlines are straight and parallel each other and perpendicular to the plane of the orifice. This section is called vena contracta. Beyond this section, the jet diverges and is attracted in the downward direction by the gravity. Right? Now, what is saying? So, in order to see the flow through an orifice, so first we have to consider take a tank, and you're having a circular type. సో మనకి ఇక్కడ వచ్చే ఓపెనింగ్ ఎలా ఉంటుంది, ఫ్రంట్ వ్యూ నుంచి చూస్తే just like a pipe. Yeah. It is a circular shape. The liquid flowing through orifice forms a jet of a liquid. So whatever the liquid is coming from this orifice forms a jet of a liquid whose area of cross section is less than the orifice, right? The cross section of this orifice area is less than of this water. The area of jet of fluid goes on decreasing at the section CC. అంతే కదా. So if you are making a section here CC, so the area is minimum. This section is approximately a distance of the diameter of the orifice. The streamlines of the streamlines are straight and parallel to each other and perpendicular to the plane of the orifice. Plane of the orifice. Then these are known as vena contracta. Vena contracta. So this is a jet of the fluid. So దీని సెంటర్ నుంచి తీసుకొని ఇక్కడ నుంచి టాప్ level of the water we are calling them as a net head, right? We are calling them as a head of the liquid. Next, so if you calculate that one considering the 2 points 1 and 2, so here 1 and here 2, considering the 2 points 1 and 2, point 1 is inside the tank and point 2 is at the vena contracta. Let the flow is steady and constant at head H. Applying the Bernoulli's equation for the points 1 and 2. So Bernoulli's equation ఏంటి, potential energy, kinetic energy and datum energy. అర్థమైందా? పొటెన్షియల్ ఎనర్జీ, కెనటిక్ ఎనర్జీ అండ్ డేటమ్ ఎనర్జీ. ఇది కూడా అంతే, పొటెన్షియల్ ఎనర్జీ, కెనటిక్ ఎనర్జీ, డేటమ్ ఎనర్జీ ఫర్ పాయింట్ 1 అండ్ పాయింట్ 2. So that is P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2. So after applying this Bernoulli's equation for this flow through orifice, now here it is on the same plane, Z1 is equals to Z2. Therefore pressure energy plus kinetic energy is equals to pressure energy plus kinetic energy. Therefore now P1 by rho g is equal to head, P2 by rho g is equals to 0 because it is to atmospheric pressure. బయట ఉంది కాబట్టి second one is the atmospheric pressure is 0. Now V1 is a small in comparison with V2 as the area of tank is very large than that of the area of the jet of the liquid. అంతే కదా, area of the jet of the liquid. Therefore H plus 0 is equals to 0 plus V square 2 by 2g. Therefore V2 is equals to root 2 GH, root 2 GH. This is the theoretical velocity. The actual velocity will be less than that of the theoretical velocity whenever you are doing problems. Okay. Now hydraulic coefficients. Hydraulic coefficients. So if you see the hydraulic coefficients for the velocity, coefficient of velocity CV, coefficient of contraction CC, coefficient of discharge CD. Okay. Now we will discuss each of these definitions. Okay. See the first one, coefficient of velocity. It is defined as the ratio between the actual velocity of a jet of a liquid at vena contracta and the theoretical velocity of the jet. Okay, what is the ratio here? The ratio between the actual velocity of a jet to the theoretical velocity of a jet, denoted by CV. And mathematically CV is given as actual velocity of jet at vena contracta divided by theoretical velocity. That is equals to V by root 2 GH, where V is equals to actual velocity, root 2 GH is equals to theoretical velocity. The value of CV varies from, so whenever you are getting the problems, the value will be varies between 0.95 to 0.99. for different orifices depends upon the shape, size, and nature of the head under flow takes place. So generally CV is equals to 0.98, which is fixed for the sharp edge orifices. Next, coefficient of coefficient of contraction. Coefficient of contraction. CC, we are calling them as a CC. So it is defined as the area of jet at Pino contractor. It is defined as the ratio of area of jet at Pino contractor to the area of orifice. Then it is denoted by CC. CC is equals to area of jet at Vino contractor divided by area of orifice. This one. ముందు coefficient of velocity, actual velocity of Vino contractor divided by theoretical velocity. ఇక్కడ area of Vino contractor divided by area of orifice. Here A is equals to area of orifice, AC is equals to area of orifice of Vena contractor. Therefore, CC is equals to AC divided by A, right? So, ఇక్కడ value ఎలా ఉంటుంది? Ranges from 0.61 to 0.69, depends upon the shape, size, and nature of discharge, and the value of CC is 0.64. So, generally, problems లో 0.64 అనేసి తీసుకుంటాం. Next, third one is coefficient of discharge. First one ఏంటి? Coefficient of velocity, coefficient of contraction, coefficient of discharge. CD. It is defined as the ratio of actual discharge from an orifice to the theoretical discharge from the orifice, denoted by CD. Therefore, CD is equals to actual velocity into actual area divided by theoretical velocity into theoretical area. Therefore, Q by Q theoretical, that is equals to actual velocity divided by theoretical velocity into actual area by theoretical area. Therefore, CD is equals to CV into CC, CV into CC, that is theoretical coefficient of discharge. Now, based upon these three types, hydraulic coefficients, also the derivation of the flow through an orifice, we will do some of the problems. So, see the first problem. The head of a water over an orifice of a diameter 40 mm is 10 meters. ఏం చెప్తున్నాడు? The head of water over an orifice of diameter. So what is the orifice diameter? 40 mm. The head H is equals to 10 mm. అంటే 40 mm హోల్ దగ్గర నుంచి సెంటర్ నుంచి పైకి తీసుకుంటే means, so this is the tank. So the orifice is 40 mm. So ఇది 40 mm diameter అనుకుందాం. This is a 40 mm diameter. So ఈ సెంటర్ నుంచి head of the water in a tank, this height is 10 meters. Okay, this one is 40 meters. Okay, 40 meters. Find the actual discharge and the actual velocity of a jet at Veno contractor, taking CD is equals to 0.6, CV is equals to 0.8. Then first write the given data as per the question. So head is equals to 10 centimeters. Sorry, ఇక్కడ మనకి 10 10 10 10 meters. Sorry, 10 meters. Okay. head is equals to 10 meters, and the diameter of the orifice is equals to 0.04 meter. Then వెంటనే మీరు ఏం కనుక్కోవాలి, ఏరియా కనుక్కోవాలి. Area is equals to pi d square by 4. That is, this is the area. Then what is the given values? CD value ఇచ్చారు, CV value as given. Now what is the first thing to find? Actual discharge and velocity of it. Therefore, actual discharge by theoretical discharge is equals to 0.6. It is CV. Okay. Therefore, theoretical discharge is equals to theoretical velocity into area of the orifice. That is equals to V theoretical is equals to theoretical velocity, that is root 2 GH. Root 2 GH, that is equals to root 2 into G into 9.81 into H and then the 10. That is 14 meters per second. Now the theoretical discharge is equals to 14 into area, and the area is this one, 0.001256. That is equals to this one, 14 into 0.001256 is equals to 0.01758 meters square by second. Then what is the actual discharge? Actual discharge is equals to 0.6 into theoretical discharge, that is equal to 0.6 into 0.1758, that is equals to 0.01054 meter cube per second. Given on the, so we have to find the second part, that is actual velocity at the Vino contract. Now actual velocity by theoretical velocity is equals to 0.98. So actual velocity కనుక్కోవాలి కాబట్టి 0.98 into theoretical velocity. So what's the theoretical velocity here? Theoretical velocity is 14. Theoretical velocity is equals to 14. That's why 0.98 into 14, that is equal to 13.72 meters per second. Meter per second. Got it? Understood? So ఇక్కడ మనకి ముందు దాంట్లో we have asked the discharge. అందుకే we have seen the actual discharge is equals to 0.6 into theoretical discharge. That's why theoretical discharge is equals to 14 into 0.001256 area. Discharge and area కావాలి కాబట్టి 14 into area, that is equal to this one. But here we have asked for velocity. Therefore, theoretical velocity is equals to, ఇందాక మనం ముందు చెప్పుకున్నట్టు, theoretical velocity is equals to 14 meters per second. Got it? Right? Next. Hope you understood the problem. Very simple problem. Direct formula. The head of water over a center of an orifice of a diameter, orifice is 20 mm, is 1 meter. The actual discharge through orifice is 0.85 liters per second. Find the coefficient of discharge. Find the coefficient of discharge. Now, what is the given data? Diameter of the orifice D is equals to 0.02. Area is equals to A into pi d square. That is this one. Head ఎంత ఇచ్చాడు? 1 meter. Then the discharge Q is equals to 0.85 liters per second కాబట్టి convert into volume, that is meter cube per second. This is the volume. Actual discharge. Then what is the theoretical discharge? V theoretical is equals to root 2 GH into 9.81 into 1, that is 4.429. Then theoretical discharge is equals to V theoretical discharge is equals to V theoretical into area of orifice, V theoretical into area. So we will getting this one. Then the coefficient of discharge కనుక్కున్నాడు కాబట్టి actual discharge by theoretical discharge. Actual discharge is this one divided by theoretical discharge. That is equal to 0.61 is a coefficient of discharge. Very simple problem. అర్థమైందా? Direct formula applying, we have to find the actual discharge or theoretical discharge. Then we have to apply the coefficient of discharge formula, that is actual discharge by theoretical discharge. Applying there, we are getting direct answer. Got it? Next, how to do the experimental determination of hydraulics of coefficient. Okay, so how to do this? So in the formulas ni, so if you are seeing practically by taking any experiment, how it is conducted, you will see now. Okay, see the first one, determination of coefficient of discharge ni manamu experimentally if you determine what is the solutions we are facing. Now see here, take a tank. The water is allowed to flow through a orifice fitted to the tank under a constant head h as shown in the figure. Now consider a water tank which is filled with the water. So e water tank make an aperture is called an orifice. Then the head is from the center of the orifice to the level is h. Okay, so మనకి వాటర్ అనేది ఈ పైప్ ద్వారా సప్లై అవుతుంది. దట్ ఈస్ అదర్ కేస్. Now the water is collected in the measuring tank for the known time. సో కింద మనము దీని సో ఈ వాటర్ ట్యాంక్, ఈ పెద్ద వాటర్ ట్యాంక్ కింద మెజరింగ్ ట్యాంక్ పెట్టేసి ఈ వాటర్ని దీని లోపల కలెక్ట్ చేస్తున్నాం. సో టేకింగ్ ఏ టైమ్ known time t. The height of the water in the measuring tank is noted down. The height of the water. So the height of the water in the measuring tank is noted down. Then the actual discharge through the orifice. Actual discharge ikkadi nunchi ikkadiki actual discharge through the orifice Q is equals to area of the measuring tank into height of the water in the measuring tank. Area into height of the water in the measuring tank divided by the time what it is taking. And the theoretical discharge is equals to root 2 GH. Now the coefficient of discharge is equals to Q by A into root 2 GH. A into root 2 GH. Okay. So ikkada entity from orifice it is falling like this. Therefore, to certain extent, x is equals to the length it is traveling, and p is equals to the pressure how it is falling, and y is equals to the downstream length. Okay, next. So this is a formula for determination of coefficient of discharge. Okay, next, determination of coefficient of velocity. Determination of coefficient of velocity. So here let C represents the Vino contractor. So from this figure, this cross section is Vino contractor of a jet of water coming out from an orifice under a constant head. Let H is the head shown in the figure. Now consider a liquid particle with which is at Vino contractor at any time and takes the position of at any point along the jet of the time t. Now x is equals to horizontal distance traveled by the particle in the time t. Y is equals to vertical distance between the P and CC. V is equals to actual velocity of a jet at V now contractor. Then the horizontal distance x is equals to V into theoretical. Okay, na? The horizontal distance x is equals to V into theoretical. The vertical distance y is equals to half mv square laga half gt square. From this equation, t is equals to x by v. T is equals to x by v. Substituting this value t into, so this t into, what you are getting, y is equals to half g into x square by v square. Therefore, v square is equals to gx square by 2y. Therefore, v is equals to root of gx square by 2y. But theoretical velocity v theoretical is equals to root 2 gh. Coefficient of velocity cv is equals to v by v theoretical. That is root of gx square by 2y into 1 by root 2 gh. That is equals to root of x square by 4yh. So దీన్ని further చేస్తే that is x by root of 4yh. Got it? Now, so this is a coefficient of velocity cv, coefficient of velocity cv. The coefficient of contraction, the coefficient of contraction is determined from the equation 7.4. CD is equals to CV into CC. Therefore, coefficient of contraction CC is equals to CD by CV. So CD మనకి ఏమొచ్చింది ఇక్కడ, coefficient of discharge. ఈ formula, okay, ఈ formula divided by coefficient of velocity is this formula. So what you are getting, the coefficient of contraction. అప్పుడు ఈ formulas ఇక్కడ అప్లై చేయాలన్నమాట. Alright, these are the formulas. So like this we have derived that practically by considering a water tank through an orifice at having a vino contact at point C. Now we'll see one problem based upon these experiments. Next, the problems. A jet of water issuing from a sharp edge vertical orifice at a constant head, h is equals to 10 centimeters. At a certain point, has a horizontal and vertical coordinates. Horizontal, vertical అంటే ఏంటి? This is a horizontal x, this is a vertical y. Keep this always in the mind. The horizontal and vertical coordinates measured from the window contractor is 20 centimeters. Here x is equals to 20 centimeters, y is equals to 10.5 centimeters. Find the value of CV. Also find the value of C if CD is equals to 0.60. Therefore, head is equals to 10 centimeters. Horizontal distance x is equals to 20 centimeters. Vertical distance y is equals to 10.5 centimeters. Then what is the CD given? 0.6. Then from this equation, from this coefficient of velocity, the value of CV is given by the formula. This, right? CV is equals to x by root 4 y h. Therefore, substitute x value, substitute y value, substitute h value. So finally, we are getting 0.976 answer. From the equation 7.7, coefficient of contraction, the coefficient of contraction. CC is equals to CD by CV. And what is CD? CD we already know on the vertical distance. CD which is already CC. CD is given as 0.6, which is in the question, divided by CV. What we have got, that is CD by CV, that is equal to 0.615. Got it? So like this, we have to solve the problem for this coefficient of value of CV as well as value of CC. Got it? Very simple and straightforward problems. Understood. So we'll do the second problem. The head of water over an orifice. Diameter orifice is 100 mm. The head is 10 meters. The water coming out from orifice is collected in a circular tank of a diameter 1.5 meter. The rise of water level in this tank is 1 meter and the time t is equals to 25 seconds. Also, the coordinates at the point on the jet measured from the Vino contractor are 4.9, x is equal to 4.9 horizontal, 4.3 meters horizontal, 0.5 meters vertical. Then find the coefficients of CD, CV and CC. Simple, straightforward question. Okay, so with this, ఈ ప్రాబ్లం చెప్పుకొని మనము వైండ్ అప్ చేద్దాం. Now, what is the head here? Head is equal to 10 meters. Then the diameter of the orifice is 0.1 meter. So వెంటనే ఏరియా కనుక్కోండి. Area is equals to pi d square by 4, that is this one. Then what is the diameter of the measuring tank? The diameter of the measuring tank is 1.5 meter. వెంటనే ఏరియా కనుక్కోండి. Area is equals to pi d square by 4, that is 7.7. Then what is the rise of water in the circular tank? 1 meter. Then what is the time taken? 25 seconds. Then the if you are measuring the Vino contractors or horizontal 4.3 meters, vertically 0.5 meters. Now theoretical velocity V theoretical is equals to root of 2gh, root of 2gh, that is equals to this one. Then theoretical discharge, Q theoretical discharge is equals to V theoretical into area of the orifice. Therefore, V theoretical into area of orifice, that is equal to 0.1099. Then actual discharge Q is equals to area into H divided by T. Then what is area here? 1.7 into 1 divided by 25, that is equals to this one. Then CD is equals to Q by Q theoretical. So what is Q? We already know that Q is equals to 0.7. This actual discharge divided by Q theoretical is equals to this one. So we are getting the value is 0.643. Therefore, the value of CC given by the equation ఇందాక మనం చెప్పుకున్న ఫార్ములా x by root 4 yh అన్నప్పుడు 4.3 divided by root of 4 into 0.5 into 10, that is 0.96. Got it? 0.96. Then CC is given by the equation CC is equal to CD by CV, that is 0.643 divided by CV96. So this is the coefficient of CD, CV and CV. So CD కనుక్కున్నాము, CC కనుక్కున్నాం and CV, CC also we have find. Okay. So we'll stop here. We'll discuss the problems tomorrow, right? So have a nice day. So I will post this video in the channel so that you can see this lecture. So thanks for watching the video. Have a nice day.